3, 2, 1. Physics!
Science rules.
I just got out of class and I learned about thermal energy. Do you know what happens when our bodies produce heat? No, what? They produce invisible fluid called caloric. Yeah, that's it.
So, a hot body has more caloric than a cold body? But that doesn't explain heat for everything else.
I know, you didn't let me finish. The scientists discovered that theory and realized that, and now made a new one. It's called the kinetic molecular theory.
What did you learn in the class?
We learned about hotness of an object. So, its temperature? Yeah, you measure temperature with a thermometer.
Oh, I know how that works. When you have a fever, you put a thermometer in your mouth and wait. It tells you how hot your body is. How does it do that? Well, it goes like this. Your body is hotter than the thermometer. So the particles in your body have a greater thermal energy and are moving faster.
Yeah, that's right.
Yeah, but I still don't get how the thermometer knows how hot I am. The thermometer is made of a glass tube, or sometimes plastic. And when the cooler thermometer touches your hotter body, the faster moving particles in your body collide with the slower moving particles in the thermometer.
But what does that all mean?
Energy is transferred that way. It's called conduction.
Like, on a train?
No, that's a conductor. I mean like science. The transfer of kinetic energy when particles collide. Whoa, whoa, whoa. Now we're talking about transferring energy?
I know all about that. Didn't you just think that conduction was on a train? Obviously, I was kidding. Now, where was I? Oh, yeah. Energy transfers. Radiation, convection, and conduction.
What do they do?
Radiation is the transfer of heat through charged particles. Think about the sun. It heats us by radiating heat.
Yeah, I've heard about that before. What about the others?
Convection is the transfer of heat through an object and its environment. Like an oven. That's an example you can use. Okay, that makes sense, but what about conduction? That's the transfer of heat through a physical contact, like putting a pot of water on the stove to boil.
Hey, that makes sense. Wait, I was thinking about something. Can we go back to talking about temperature? How do you know what the numbers mean? Like the freezing point and boiling point and stuff.
Oh, temperature scales. Yeah, I was wondering that too.
I have the answer for that. Okay, so there are 3 ways to measure the temperature of something. The first way is Celsius. The freezing point in Celsius is 0 degrees. And the boiling point is 100 degrees. Absolute zero, which is the lowest possible temperature, is negative 273.15 degrees.
Why isn't absolute zero just zero? And everything else go up from there. It just makes sense.
Because that's Kelvin. Absolute zero is 0 Kelvin. Freezing point is 273 Kelvin. And boiling point is 373 Kelvin. But what about the one that we use all the time? It starts with an F, right? You're right! It's Fahrenheit! Really? Nothing? Okay. Freezing point for Fahrenheit is 32 degrees. And boiling point is 212 degrees.
What about absolute zero?
Oh yeah, that's negative 459.67 degrees. Very cold.
Well, how do you increase temperature?
The basic way to increase temperature would be to put an object in contact with a hotter object.
Oh, I knew that.
Want to know some other cool things about temperature and heat?
What is it?
The way it affects the different phases of matter. You know, solid, liquid, and gas.
Tell us how.
Okay, so it's actually really simple. If you have a solid, like ice, you would add heat to it and it will melt, turning into a liquid. And then, if you keep adding more heat, the liquid evaporates and turns into water vapor. This is a very hot topic. Really? Nothing.
Stop trying. Anyways. What about specific heat? How do I measure that?
Calorimetry. Calorimetry is a way to measure specific heat.
Okay, but how?
A calorimeter is a device that measures changes in thermal energy. It is carefully insulated so that the heat transfer is very small. The operation of a calorimeter depends on the conservation of energy in isolated, closed systems.
What?
If a system is isolated, energy can neither enter nor leave it. Oh, I get it now.
Is there a way to change the amount of thermal energy?
Yeah, actually. Other forms of energy, like light, sound, and electricity, can be changed into thermal energy. For instance, a toaster uses electric energy to convert it to heat. Thermal energy can be increased by adding heat or doing work on a system. The total increase in the thermal energy is the sum of both those things.
Oh, okay. My brain is totally satisfied.
Three, two, action!
Hello, it's me. I sniff my food before I eat it. Procky!
Hello, it's me.
Today we're going to talk about thermal energy.
My eye's falling off. No! Oh no!
Hello from the other side.
Oh no! Hello, it's me. Physics. If you eat chips with sock monkey hands, we're fighting.
We should-
Failing is not an option.
Yeah, you measure temperature with a thermometer.
I will kill you with these sock puppets.
Hello?
It's me.
Nothing. I'm at a friend's house filming a video. They produce invisible fluid. It's called caloric.
It's caloric.
They produce invisible fluid. It's called caloric. Yeah, that's it.
It's caloric.
They produce invisible fluid. It's called caloric. Yeah, that's it.
You did it again.
Did I seriously do it again? What the